Hello, everyone. We are going to practice or going through the sum solutions related on the determinant. That is chapter 3. I'm going to solve question 34, 35 in this video for the course Math1151 at UNSW. What we are focusing on in this session is how the row operations act to the determinant. If we swapping any two rows, we are obtaining from the matrix A to the matrix B by swapping to any two rows, it affects the determinant by -1 factor. If we have a row operations and we are multiplying the sum row J and adding to the row I, and we are obtaining a matrix B from matrix A, then the determinants are exactly the same. If we have row operations, multiplying a factor to any row, let's say we are multiplying alpha, we are doing these row operations to the matrix A, and we obtain matrix B. And the determinant is affected by 1 over alpha, or alpha times determinant of A is equal to determinant of B. So by knowing these, it will help us to calculate the determinant. This is what we are going to practice now. Before we start, I would like to remind you, this is the formula. This is the formula for the first row. So this is the determinant. This means as a determinant of A. Sometimes we use the notation determinant. Sometimes we use just as straight lines. This is a determinant of A as a notation. Is equal to sum. I am opening up with respect to the first row. You can open up like this with respect to the any row or any column. So this 1 is fixed for this case. You can fix for any I or J. And as a matter of fact, we choose with respect to the determinant, if you have lots of zeros in one row or lots of zeros in one column, we open up with respect to that row or that column so that our calculations will be a lot shorter, a lot easier. Yeah. This 1 represents, so this is -1 in the position, and the 1 is the first row, and K represents the column. So this is the column number. So this is the entry of the matrix A in the position 1K, and this is the minor. What does a minor means? Minor, when you remove the first row of K column, whatever the matrix that you left there, that's that matrix. So A1K is the one less dimensional matrix which you obtain by removing the row 1 and column K. Now we are going to practice this. Let's see this in an example. This is in your notes, is the question 34. Let's do the determinant. Now we have ones a lot here and ones a lot here. We can use the row operations and make these columns are 0. And we can open up with respect to this column because we will have zeros. This is the idea. So if we are applying row, for example, row 2 is equal to row 2 minus row 1. So that will give us this position 0. This is how I got from here to here. And also I am doing row 3 minus row 1, and row 4 minus row 1. So this means that I'm getting those ones 0. From here I have 0. From here I have 6. From here I have 0. This is what I've got there. So for this row, I have 7, that's 7. I have 2, that's 2. I have 0, that's 0. From here, this is 0, this is 0, this is 0 for all of those. -1 plus 4 is 3. So we get this matrix. According to, so I am going to apply this formula. The formula says I am opening up with this. So this entry is 1, and that's -1 the position row number plus the column number. Row number is 1 and the column number is 1, so I have 1 plus 1 here. So this one is this one, and then this A11 is the big, A11 is the minor, that's what we call 1, 1 minor, is the matrix that we are going to obtain by removing the first row, first column. If you remove first row, first column, this is the matrix that we are going to get. So that is this matrix, and this is the determinant. So the straight line means the determinant, means the determinant of this matrix that we are interested in. Now, here we can do different things. We can choose any row of any column. We have lots of zeros. I choose the first row, second column. I choose the first row, but this one I have only 6. So that's the position I only needed to calculate. So 6, this 6 is this number. I have -1, and above is the position of 6. Where is the 6? 6 is the first row, second column. This is, I have 1 plus 2. This is 1 plus 2 represents the first row, second column. And then the minor. The minor, when I am removing this row and this column, when I remove this row, this column, I have 7, 0, 0, 3. If the whole matrix is B, and then the removing B12, B12 will be the minor, is another way of saying it. So this is 6, and this is minus, and the determinant of this 2 by 2 matrix, this times this minus this times this. So this is 21 minus 0. So that's -6 times 21. That is -126. I hope this is much more clear now, how to do the determinants. Okay, needs to be practiced a little. Let's do the question 35, and let's solve this one. Now, in this question, the determinant of such matrix, let's call this matrix A, and we don't know A, B, C, D, E, F, H, G, I, it could be anything, and this is given to us as 5. And the first part of this question is asked, if we know this one is 5, what will be determinant of this one will look like? So the idea is that we are practicing how the row operations affects the determinant. That's what is the exercise all about. So because we have a matrix A, we have a matrix B. We can obtain matrix B from matrix A. So these row operations, we multiply the first row by 3, right? So this is the act by a factor 3. So row 2 is multiplied by 2, row 3 multiplied by -1. Let's have a look what was the formula is. If we are moving from A to B by multiplication of alpha, determinant is affected by 1 over alpha. So we can say determinant A is equal to 1 over 3, 1 over 2 minus 1 is equal to determinant of B, or you can write determinant of B is -6 of the determinant of A. Determinant of A is given by 5, so we have determinant of B is -30. It's pretty straightforward. Let's exercise a bit more. The B section gives us this kind of determinant. We know that determinant of A is 5, but all the row operations here is second row multiplied by 2, adding the first row, does not affect the determinant. This one, multiplying the last row, adding to the second row, does not affect the determinant. So, and the last row, we didn't do anything. So determinant of this matrix is exactly the determinant of A, which is 5. And yeah, all the operations that we are doing here is of this kind. Row I is equal to row I plus alpha times row J, so it doesn't affect the determinant. So in here, some of the rows are swapped. So this is the this is supposed to be the first row, this is supposed to be the last row, and this is supposed to be the second row. So each time that you're swapping the rows, the determinant is affected at the -1 as a factor of -1. So row 1 goes to the row 3, row 1 goes to the row 3, and then we have row 2 goes to the row 3. So there are two ways of doing this, but so you have only two highs you are doing this. That's my point is. So if you do swapping row 1 to row 3, so you have, sorry, in the first swap, that will be -1 of the determinant of 1 to 3. A, B, C. Okay, let's do it that way. A, B, C. And G, H, I, I'm leaving it here. And then the last one will be D, E, F. Now I am swapping again. That's give me another -1. I need to swap row 2, row 3 this time. I've done it with my eyes, but I think it is better to write it down. Okay, this is what I was saying. So this one -1, -1. So this is -1 squared now, because from here to here, again, I swap 2 rows. Then I have another -1. It means that the determinant of this matrix is equal to the determinant of A, which is 5, because nothing, okay. I think that's that part. How about determinant 7A? Now, for this case, 7 is the scalar and A is the matrix. When you're multiplying a scalar with the matrix, you're multiplying that scalar with every element in the matrix. It means that you are multiplying every row with 7. So you're multiplying the rows, row I goes to the row I, 7 row I, but for each I is equal to 1, 2, 3, because you have a 3 by 3 matrices. Then you have this alpha, and the determinant will be affected by 1 over alpha, 1 over 7. But you are doing this 3 times for each row. Then you have determinant of A is equal to 1 over 7 determinant cube. 1 over 7 the cube, and the determinant of 7A. So determinant of 7A is 7 cube times 5. That's what it is. So we can do this way, or there's another way, there's another explanation for the solution for this one, because determinant 7A can be written as 7 times the identity and A. So you can think of this one 7I, A. I is the identity matrix. So I'm thinking about this one as a multiplications of 2 matrices. Multiplications of 2 matrices can be, so this is what I'm doing here. Determinant A, this is what I'm thinking about. Determinant A times B is equal to determinant A, determinant B. I'm using this rule and thinking this one as multiplications of the 2 matrices. One of them is the 7 times identity, another matrix A itself. The determinant of the 7 times identity matrix only the 7s on the diagonal. So you have 7 cube, and determinant of is 5. Both of them are perfectly fine answers for this question. For this video, that's all I would like to say, and thank you very much. I hope it is clear for you all.